Imagine you're on a spacecraft, not cruising through calm open space, closing in. Jupiter is ahead of you, filling the entire viewport, and it's still getting bigger. You're not landing. You'd never land. There's no surface to land on. You're going to fly past, skim the outer atmosphere, and get out. That's the plan. But even from this distance, something feels wrong. The storm you're looking at, the one that looks like a bruise on the planet's face, it has been spinning continuously for at least 350 years. Nobody knows when it started. Nobody knows when it will stop. And here's what that storm actually tells us about Jupiter. It's not a planet in the way we usually mean. It's not a rocky world with weather on top. A ball of hydrogen and helium so massive it almost ignited. And everything around it, including us, exists partly because of what Jupiter did 4.5 billion years ago. This is not the friendly gas giant from your school textbook. This is the most violent, the most powerful, and arguably the most important object in the solar system. Today, we go deeper, not just to meet Jupiter, but to understand what makes it extraordinary. Jupiter is the largest planet in the solar system. But that sentence doesn't begin to capture what we're dealing with. Jupiter is 1,300 times the volume of Earth. If Earth were a grape, Jupiter would be a basketball. You could fit every other planet in the solar system inside Jupiter and still have room left over. Its mass is 2.5 times the combined mass of every other planet, moon, asteroid, and comet in the solar system. Combined, it's so massive, it actually makes the sun move. But size alone isn't the story. The story is what Jupiter is made of. There's no surface, no crust, no ground. Jupiter is almost entirely hydrogen and helium, the same stuff stars are made of. As you go deeper into the atmosphere, the pressure builds. The gas gets denser. And at a certain depth, something strange happens. The hydrogen stops behaving like a gas and starts behaving like a liquid. Go deeper still, and the pressure becomes so extreme that the hydrogen transforms into something that has no equivalent on Earth. It becomes metallic, a substance that doesn't exist anywhere else on Earth, something we can't even recreate in a lab. It conducts electricity like a metal, but it flows like a liquid. But to understand what Jupiter really is, you first need to know what it almost became. This dark, stormy giant almost became something else entirely. Jupiter is made of the right stuff to be a star: hydrogen, helium, the same ingredients the sun used. What stopped it? Mass. To ignite nuclear fusion, to become a star, Jupiter would need to be somewhere between 13 and 80 times more massive than it is. It has the ingredients, but not the quantity. It sits just below the threshold, a near miss, on a planetary scale. Some astronomers call Jupiter a failed star. Others prefer sub-brown dwarf. The label doesn't matter. What matters is what this almost star does. And it doesn't just sit there passively. Jupiter radiates more heat than it receives from the sun. It glows, faintly, from the inside. Its magnetic field is roughly 20,000 times stronger than Earth's. If you could see it with your naked eye, it would appear larger in the sky than the full moon. Not the planet itself, but the magnetic bubble surrounding it. This magnetosphere swallows several of Jupiter's moons entirely. It stretches almost to Saturn's orbit. It is the largest structure in the solar system. If you were standing on one of Jupiter's inner moons right now, the radiation dose you'd receive would be fatal within minutes, not hours, minutes. And that's just the magnetic field. The atmosphere itself is something else entirely. Jupiter's atmosphere is not calm at the top and violent underneath. It's violent all the way down, at every level, in every direction. Wind speeds in the upper cloud bands reach 620 kilometers per hour, sustained. These aren't gusts. These are permanent deadly winds. And that's only part of it. Jupiter rotates faster than any other planet in the solar system. A Jovian day is just under 10 hours. A planet this massive, completing a full rotation in just 10 hours. The speed is almost hard to believe. It actually flattens the planet. Jupiter is noticeably oblate. That fast rotation is what drives the bands. And inside those bands, at the edges where wind systems collide, are the storms. The most famous and the most terrifying is the Great Red Spot. It's a storm system wider than Earth. It has been observed since at least 1831, and there's reasonable evidence it may have been spinning since the 1660s, which means it's been going for over 350 years. On Earth, even the most powerful hurricanes collapse after a few weeks. The Great Red Spot has outlasted civilizations. And if you could descend into Jupiter's atmosphere, the last thing you'd see before the instruments failed, before the pressure crushed everything, would be lightning. Jupiter's lightning is not like Earth's. The bolts are thousands of times more powerful than anything on Earth, and they cluster near the poles, not the equator. We can detect them from space as radio bursts. The Juno spacecraft, currently in orbit around Jupiter, records them constantly. The atmosphere is chaos, top to bottom. But the atmosphere isn't even the most extreme thing about this planet. For a long time, we thought Jupiter was simply the largest planet, sitting in the outer solar system, minding its business. Then we started building better models of how solar systems form, and Jupiter's role turned out to be something no one expected. 4.5 billion years ago, the solar system was a disk of gas and dust rotating around a young sun. Planets formed by accretion, dust stuck together to form rocks, rocks to form larger rocks, and eventually full-size planets. Jupiter formed fast, probably within the first few million years, and then it moved. The consequences of that journey were catastrophic for the inner solar system. As Jupiter moved inward, it scattered material. Rocky bodies that might have formed a larger Mars or another Earth-sized planet were thrown outward, inward, or entirely out of the solar system. Mars ended up small and underweight. The asteroid belt, which sits between Mars and Jupiter, is essentially debris that never assembled into a planet because Jupiter kept disrupting it. Without Jupiter's inward migration and retreat, the inner solar system would look completely different. Earth might not exist, but Jupiter didn't stop there. Once Jupiter settled into its current orbit, it became the solar system's shield. Its gravity pulls in asteroids and comets that would otherwise head straight for us. In 1994, the world watched as a comet broke apart and slammed into Jupiter. The largest impact scar was bigger than Earth. If that comet had hit us instead, the extinction event would have made the one that killed the dinosaurs look minor. Jupiter has taken impacts for us for billions of years, silently, without us knowing. We exist, in part, because of a planet 600 million kilometers away. We've been sending spacecraft to Jupiter for decades, and what we found changed everything we thought we knew. Voyager 1 and 2 arrived in 1979. They discovered that Jupiter had rings, thin, dark, nothing like Saturn's, but rings nonetheless. They found active volcanoes on Io, one of Jupiter's moons, the first active volcanoes ever observed on another world. They found evidence that Europa, another moon, might have a liquid water ocean beneath its ice surface. That last discovery changed everything. Europa is now one of the most important targets in the search for life beyond Earth. The ocean beneath its ice is estimated to contain more liquid water than all of Earth's oceans combined. And where there's liquid water, there's heat. The ingredients for life, as we understand them, might exist in that hidden ocean right now. We went to Jupiter expecting to find a large, unremarkable ball of gas. We found something that shaped the entire solar system, that holds a candidate for life in one of its moons, and whose interior we still don't fully understand. Every time we look closer, we find more. Jupiter has been here for 4.5 billion years. It was here before the first single-celled organism appeared on Earth. It shaped the conditions that made our planet habitable. It absorbed impacts that would have ended life before it really started. We live in a solar system with a specific architecture, a specific arrangement of planets, belts, and gravitational relationships. That architecture is not random. It was sculpted, in large part, by Jupiter. And it is this particular architecture, with Jupiter in roughly this place at roughly this mass, that allowed complex life to develop on a small rocky planet in the inner solar system. Jupiter is 600 million kilometers away at its closest point. It's a bruised, violent, beautiful, lethal world that we can barely visit and cannot begin to inhabit. And yet it is, in a very real sense, part of the reason you're watching this. It was always there. We just didn't know what it was doing.